We can see everything.
Okay, I can go.
Absolutely. Go
Okay.
for it.
Yeah, thanks, Sarah. Thanks for having me, and thanks for everyone for joining me on this presentation. I'd like to just talk about septic and well inspections, and basically, what to look out for when you're looking at homes that have septic and well systems. So we'll go. We'll start first with a septic system. Basically, this slide just is an overview of a septic system. There's quite a few different types of systems that we'll get into in a little bit, but this is what we call a conventional system. This is basically going to be the most common type of septic system for any home that's built within the last 30 years or so. So basically, what this shows is a conventional system consists of what's called a septic tank, and then what's called the leaching field. So the septic tank basically gathers the solids in the tank from the home, and then the clear liquid, we call that effluent, that's discharged out into the leaching field, which are basically a series of pipes that sit inside trenches filled with stone. And then that's basically where the bacteria grow and where everything gets digested. So a quick overview of what's called the conventional septic system. We'll get into kind of some of the details and some of the different types of systems that are now available. So this is a schematic of a septic tank. So this is a modern type of tank. Basically, newer style tanks have two chambers. So we'll have what we call the inlet chamber and then the outlet chamber. You may also hear the words solids and liquid side, because basically all the waste comes through the inlet pipe, and the sludge, which is anything that settles to the bottom of the tank, that's forms a layer on the bottom called the sludge layer. Anything that floats, we call that the scum layer on the top. And then we get a clear layer in the middle, that's called the effluent layer. And that layer is able to go over into the outlet side through openings about halfway down this interior baffle wall. So the solids stay behind in this in the inlet chamber, and we get clear liquid or effluent in the outlet chamber, and then everything goes out through the outlet pipe to the leaching field. So with older systems, you're probably not going to see the lids. They're going to be buried. But with newer ones, you'll likely see two green lids coming up to the surface. So that's a schematic of a septic tank. So we have a few different types of systems. It's kind of good to know what's out there, what's available. We've already kind of talked about the conventional system. You may also hear it called pipe and gravel. It is the majority of older systems. It's still used today, but the main issue with these systems is they do take up quite a bit of room. So with lots getting smaller in rural areas, sometimes these systems just don't fit. So there's other units available. The next one down would be called a sand filter bed. So basically, I like to say, if you ever are driving around and you see like a big hump in someone's yard, that's likely a sand filter bed. So it's got some advantages and disadvantages, but we'll talk about that in a couple different slides coming up. And then we'll have what are called advanced treatment units. So you'll see these on newer homes, particularly large homes that are on smaller lots. And these are basically third-party manufactured septic systems that are approved under the building code. So the main ones in use in our area would be the Waterloo biofilter. You would also probably see EcoFlow, and then there's also another one called an LGen system. We'll talk about each one and how to identify them and kind of how they work. But their main benefit is that they take up a very small footprint. And the reason they do that is because a lot of the treatment of the waste is done before it's released into the leaching field, whereas a conventional unit, the majority of treatment is in the leaching field. These units treat the waste inside of tanks or sheds, as we're going to see. So by the time the liquid is ready to go back into the ground, it's very, very clean. So that's the main advantage of these type of units. You may also see, especially on smaller lots, especially lakefront property, you may also see holding tanks. So a holding tank basically is just a tank to gather waste. Nothing leaves the tank. So everything from the home accumulates into the tank, and when it's full, we have to go and pump it out. So obviously, they're not highly favorable if you can avoid them. Generally, they're not even allowed under the building code if a septic system can fit on the lot. But that's a real challenge in some of these lots, especially because we have to be certain distances away from water, certain distances away from neighboring wells. So sometimes we just cannot fit a septic, conventional septic or any other kind of thing.
Yeah, most of it's all land I know of, so we never change it.
Okay, so that's the types of septic systems. We'll go into each one and kind of describe how they work. And normally these are buried, so you don't see them, but this will kind of show us how they look when they're installed. So absorption trench, that's the conventional type of system. This is the majority of systems. They're very simple how they work. There's a septic tank, and then the effluent leaves the tank and comes into a series of trenches that are filled with stone. And this pipe here, this white pipe, it's perforated, so it has holes in it, and the effluent basically goes into the ground. The stone is there because stone traps a lot of air, and that's where all the bacteria grow, and that's where the treatment is done. So the advantage is it's relatively inexpensive. It's probably the least expensive type of system to install. But the main disadvantage, that's the reason we're not seeing a lot of them anymore on newer properties, is they require a large amount of space. So, and basically with septic systems, the leaching field is pretty well off limits for any kind of other development in terms of putting sheds or patios or pools and things like that. So these systems are not as common anymore. This is a filter bed, and you can see it's a pretty compact system. It's really used if the soils are very sandy, so it kind of uses the natural sand in the soils to spread the effluent through. But it's also a good system where the water table is high. So if we can't dig trenches because we're going to hit the water table, then the system has to be raised up, and that's done through a filter bed. The disadvantage of these systems is usually they're put in because the system does have to be raised. So you're going to see a big hump, and it's a very pronounced hump because it's basically over top of the pipes, which is a pretty small area. But that doesn't look very good. So that's one of the main disadvantages of these systems. And we have to have what's called a mantle on these type of systems. So we have to have some kind of a sand area that spreads 15 meters away from the pipe. So that can be a restriction depending on the lot as well. But they generally do take up less space than the previous system, the absorption trench. So it's still a good option for a smaller lot, but especially a good option where the water table is high, especially near lakes or rivers. So these are, we'll get into some of the more common advanced units. So basically I would think the most common one now is called the Waterloo biofilter. And there's a few different options to the Waterloo biofilter. There's what's called the shed type. So you'll basically see a shed in the middle of a yard somewhere, and you'll try to open it, but you won't be able to open it. That's probably a Waterloo biofilter shed. Or they could be inside of tanks. So these are called the basket biofilters. So you may see multiple green lids on the grass. And that's probably a good indication that's a Waterloo biofilter. Basically, how these units work is, I might have in the next slide. No, I don't. Basically, these units are full of foam blocks, like little tiny sponges. In the biofilter, in the basket biofilter, they're just inside of these round baskets, just full of foam sponges. In the shed, they're all inside this shed. So basically what happens is from the septic tank, the effluent is sprayed onto the foam blocks or sponges. And it's a sponge, so there's a lot of air in it. So that's where the bacteria treats the effluent. So you can see now that the treatment of the effluent is done prior to releasing it back down into the ground. So in terms of a shed, we can see that the stone here and the sand layer, the shed is basically open on the bottom. So by the time the effluent trickles down these foam sponges, it's very clean. It just gets released into this stone layer and into this sand layer. So that's the main advantage of these systems, is they take up a very small footprint because the effluent is treated before it leaves. It's put back into the ground. The other system you may encounter or hear about is what's called an EcoFlow system. By the way, just backing up, Waterloo Biofilter is a Canadian company. The technology was developed at the University of Waterloo. The units are made in Guelph. The EcoFlow is also a Canadian company. It's based out of Quebec, and it uses peat moss instead of foam. So peat moss has a good property as well, that it traps a lot of air. There's a lot of air spaces, and it's a very durable material. And basically the effluent is sprayed or basically spread out over top of the peat moss, and that's where the bacteria grow. And same thing as the Waterloo, the bottom of these units are open, and the clean effluent basically goes back down into the ground through a layer of sand or stone and sand. You wouldn't see all this. This is before backfill, but you would just see the green square lid, and that would be at grade, and then the rest would be covered. And then you'd see the two lids on the septic tank. So it still has the advantage of taking up a small footprint. A bit of a disadvantage of an EcoFlow is that the peat moss does have to be replaced. So basically all these advanced systems do require yearly inspections. So typically when they're installed, there's a maintenance contract that gets signed with the supplier of these systems. And once a year, one of the technicians comes out and looks at everything, make sure it's working properly. But with the EcoFlow, they will kind of identify if the peat moss has to be replaced. Ballpark costs of replacing a peat moss, I've heard kind of anywhere from like $3,000 to $6,000, depending on the type of the system or how large it is. So definitely a bit of a cost that's associated with these units. So these are called the EcoFlow. This is a very common one that's coming now. It's relatively new. Well, at least to us, it's a US product. But basically in Ontario, probably only within the last 10 years. This is called an LGen system. So you probably are not going to know about this system because in terms of being able to spot it, because these are buried modules. So it's basically like a trench system, a conventional trench, but instead of using a layer of stone, they use these plastic corrugated modules. How these are constructed is there's filter cloth and there's air spaces in these modules, and that's where the bacteria grow. So instead of the bacteria treating inside of a tank or in a like an EcoFlow or a Waterloo, the bacteria grows inside of these modules. And by the time the effluent goes down back into the ground, it's treated. So they still have a benefit of being very compact as well, but the modules are buried. So you probably wouldn't see the evidence of this. So that's called an LGen system. So there are a few other different technologies, but these would be kind of the main ones that we're seeing in our area. I'll just briefly go over kind of how I would do an inspection, and certainly some of this could be done even when you're touring a house. Of course, you're not going to open up the tank, but there could be some signs that the septic system's not working properly. So basically, I always get the question whether I need the tank to be pumped out. So you can read up on this. There's always two schools of thought on this, that you can't inspect a tank without pumping it. Well, I kind of belong to the school of thought that the tank does not need to be pumped out. And the reason for this is that the majority of any kind of damage or deterioration of a septic tank, it happens above the water line. So basically in a septic tank, it's never full to the top. There's always a space, usually around 8 inches to a foot on the top. That's where basically there's hydrogen sulfide gas, and that's gas that comes back from the leaching field. So that's the gas that deteriorates the tank. So normally that's all visible from the surface, basically without pumping the tank. The majority of the time when a tank gets pumped, the condition of the tank below the water line is basically like the day it was installed. It's in really good shape. Also, I perform what's called a load test, which is basically running water through the system. So normally, in the winter, this can only really be done by running bathtubs or sinks and things like that through the septic system. So if the tank is empty, obviously I'm not able to test the leaching field to see if it's working properly. It can be done in the summer with a hose, but it can be difficult in the winter. So I do come prepared to dig up and remove the septic tank lids. I just use a shovel. We're not bringing in heavy equipment, so sometimes it's just not possible if the tank is too deep or covered by a patio. But the majority of the times it can be done. I use a sewer camera to inspect the sewer from the house to the septic tank, a sewer camera to inspect the septic tank above the water line where the deterioration would happen, and then the sewer camera from the outlet pipe into the leaching field. All those videos get recorded and uploaded and put into a report. So we're also monitoring the water level in the outlet pipe just to make sure it's not backing up. And then typically I'll dig what's called a test hole in the leaching field, which is a small hole near one of the pipes or whatever kind of system it is, just to make sure that the liquid or effluent is going down and not coming up. So we'll see in a few slides what we don't want to see. So that's the procedure. That's the inspection camera that I use. It records video. It has sound, so you could hear narration or voices, things like that. So here's some of the issues that we may see with septic systems. Standing water in the inlet and outlet pipes. So I'll show you a few pictures. Backed up septic tanks. Obviously, we don't want to see that. Deteriorated inlet and outlet baffles. These are very common issues in septic tanks. Luckily, they can be easily fixed. Deteriorated tanks, the interior baffles, that's the wall in between. And sometimes the tanks, especially the older concrete ones, have cracks in them, so have become pretty unstable and not safe. We may see sludge in the outlet pipes or the distribution pipes. And during the load test, if the septic system starts to back up, that's not a good sign. That's telling us the leaching field is not taking that effluent. Also, we may see a breakout of effluent in the leaching field. This is a little more rare, but we may see this. And in the test hole, if we see water coming up to the top, that's not a good sign either. So just some pictures here. I know it's not that clear, sorry. Standing water in a pipe, obviously it's a freezing risk because septic systems, if you saw some of those slides, you see that these pipes are not very deep in the ground. And the reason for that is because we need a lot of air to get into these pipes and into the stone. That's where the bacteria grows. So we can't put these pipes very deep. But once you have standing water in one of these pipes, meaning the water's not draining properly, definitely you could get some freezing. Becoming less of an issue, I'm finding, but certainly every season I kind of hear about a septic system not working at all, and the reason is because it's basically frozen. So if I lift up a lid to a tank and this is what it looks like, that's a really bad sign. Like I said, there's normally about 8 inches of air above the liquid in a septic tank. So if it's up to the top like that, there's definitely a big problem. This is a very common, is deteriorated outlet baffles. The outlet baffle basically acts as a dam or a shield around the outlet pipe. It's a really important part of a septic tank because you can see in this picture, this stuff on the top, that's called the scum, the floating scum layer. We don't want that to get into this pipe. So once these baffles deteriorate over time, they start to crumble below the water line. So you can kind of see the scum is able to get into now the outlet pipe, and you can get sludge buildup and everything basically can plug up. So luckily, it's a simple fix, but we have to catch it in time. So that's definitely something that's really looked at carefully during a septic inspection. This we wouldn't see without using the camera. This is some deterioration of the interior baffle wall. That's the wall that separates the inlet and outlet chambers. This one's not too bad right now. You can see it so bad that it crumbles below the water line. And same thing, we get scum from the inlet chamber going out to the outlet chamber. It's a picture of a crack. Something ran it over. So this was spotted through the camera inspection inside the tank. This is a deteriorated baffle wall, similar to the last slide, but this is quite a bit more. So now you can see how the scum layer is able to get over to the other side, whereas this wall at one time went all the way across. So this is a very common problem in concrete septic tanks, which the majority of septic tanks are still concrete. Some of the newer ones are plastic now. Sludge inside of the distribution pipe. So this baffle was probably deteriorated for a long time, and you see the accumulation of the sludge in the pipes, and that'll definitely start to plug things up. And then this is like a complete failure. Luckily, we don't see this very often, but probably 3-4 times a year I'll find this, where basically the effluent is coming right up to the top. So obviously that's really not a good condition. It's very dangerous. That's a lot of pathogens and bacteria are in that effluent. This is a picture of a test hole, and you can see that it's filling up with liquid as well. So even though the liquid hasn't come up to the surface, it's certainly high in the test hole, like even above the pipes. So that's not a good sign to it. The system is starting to fail, even though the effluent hasn't come up to the top yet. Okay, so we'll cover wells. Sorry if I'm going a little quick because I just wanted to save some time for questions. This one will go a little bit quicker. So types of wells. The majority of newer wells are called drilled wells. I'll show you a picture of those. And they'll have a submersible pump in the well. So the pump will be in the well. Some of the older wells, they're called dug or bored wells. So they're typically a very large diameter concrete well tile. And they'll usually have a jet pump inside the house in the basement. Some of them can have a submersible pump in the well, but the majority would have a jet pump in the basement, so not in the well. Well pits, these are kind of an older style of drilled wells. They actually are drilled wells, but they're in a pit. So they look exactly like a dug or a bored well, unless you open up the lid and you'll see the well inside the drilled well. So I'll show you a picture of these. They are not allowed anymore. They're confined spaces, but like anything kind of older, grandfathered, we don't have to replace them. But I do like to explain to people that they're confined spaces. So definitely need to follow a certain procedure when we're working in a well pit. A sand point, if you're ever walking around a property and you just can't find the well, you just can't find anything coming up to the surface. And if you know it's a sandy area, you know, in our area, like around Sharon or East Gwillimbury, these were very common. I'm seeing a few near Alliston, Caledon, just kind of generally sandy areas. It could be a sand point well. So these are basically underground, very shallow wells. Not very common, as I said, but if you just can't find a well, it's possible that it's a sand point. So this is a schematic of a typical drilled well. This is like the majority of wells that we'll see. You will see the well casing coming up to the surface. There will be a pump down in the well. There's a device called a pitless adapter that basically allows the water to come into the home underground. In the basement or in the house, you're going to see a pressure tank, which is usually a big blue tank, and then the pressure switch with some electrical components. So this is like the common type of well arrangement. So this is what it would look like from the surface. So it's usually like a 6-inch diameter steel casing with a gray lid. Sometimes, if we get lucky, you'll see this well tag on it. That's called the well ID tag, and you can use that to search for what's called the well record. You can search for a well record without the tag number, but it's a lot easier. Otherwise, you have to kind of use the map under the Ontario website. It's actually the Ministry of Environment, but I just typically Google Ontario well records and it'll come up. And there's a mapping feature where you type in the address and it'll just basically show you blue dots, and you pick on the dot that you think is the closest one, and it'll bring up the record. This is a dug or bored well, so this is pretty common in older homes, homes that are close to water, where the water table would be high. Just basically a large concrete cylinder, and when you open it up, I mean, some of these are pretty heavy, but you would see water inside of it. So that's typical of a dug or a bored well. Well pit, the well pit will look exactly like this from the surface, but when you open the lid, this is what you're going to see. You're actually going to see a drilled well down at the bottom of the pit. And the reason we did it this way is because we didn't want any of these connections to freeze in the winter. So we would typically put this pit down, you know, about 4 feet, 6 feet, so that these piping connections wouldn't freeze. Now, if you remember in the previous slide, there's something called a pitless adapter, and that's how it got its name. That's a quick connect fitting where we don't need to get down into a pit anymore. We can just put a tool from up above and pull everything out, pull the pump out through a quick connect fitting. So we don't need pits anymore, and they're not allowed to be constructed. You can still have one if it's existing, but we can't construct the well this way anymore. This is an image of a submersible pump. You'd probably never see this. This lives its entire life down inside of a well. They're all stainless steel. They're very well made because typically you don't want to replace these very often. It's quite a procedure to pull out a pump and replace it. So typically, hopefully, you can get 20 to 25 years out of a well pump, but they are very, very high quality. This is what's called a jet pump. This is what you would see in the basement. So the advantage of a jet pump, it's relatively inexpensive and pretty easy to replace one of these. It's just done in the basement or sometimes in a crawl space. But the disadvantage of a jet pump, typically they don't give you as much water as a submersible pump. So just the physics of it, the submersible pump pushes water. The jet pump sucks water out. So it's just a submersible can give you a lot more water. So here's my inspection procedure for a well. I do take water samples. So I've kind of made this just something I do all the time now. It used to be kind of an option, but I just find people always want to have a bacteria test. And I know, you know, you as agents do this as well, but I've just been asked so many times that I just kind of made it part of my procedure. So I do take a bacteria test. I use a private lab. So I find quicker than using the health department labs. I can usually get the results back within 2 days. So it just depends on timing and if there's a weekend or a holiday in between. I can take 2 samples. Usually we just want to take the sample after water treatment equipment. But if you really want to know what's coming out of the well, I could take a sample before the water treatment equipment. I search for the well record online. I try. I mean, if any of you are experienced with the ministry site, it's kind of hit or miss with these well records, especially the older ones. I do remove the well head cap or the dug well lid. The reason that is done because I use an electronic measuring tape to establish the water level. So we want to know where the water's at before we start running the water. And if it's a submersible pump, I want to measure where the pump is, and that tells me how much water is above the pump and how much water we can use. Then I perform a flow test. We typically like to see 3 gallons per minute for 1 hour. If we can get that's a good well. I monitor the water level in the well with the equipment. I measure the recovery. Sometimes I don't need to do that if it's a good producing well, but if the well constantly drops down, meaning I'm going to run the well dry, then I'll have to turn off the pump and measure the recovery to get the flow rate of it. And then inspect the interior components like the pressure tank, the pressure switch, the fittings, things like that. I'll show you kind of the equipment. That's an electronic tape. It basically, once it touches water, it beeps. So it's pretty simple, but a good tool just to tell us where the water level is at. And some of the issues with wells that we can have, some of the older ones, we may see that they're too close to a septic system. They could be damaged in terms of the well caps or lids, so surface water and contamination can get into the well. Too close to grade, so there is definitely a minimum kind of requirement how high up the wellhead has to be. Some of them unfortunately run out of water, so don't pass the 3 gallon per minute for 1 hour test. Then there's water quality issues. So we could have smelly water, We could have the bacteria in the water, or waterlogged pressure tanks. That would be a pressure tank that doesn't have air anymore. So that means the pump is always going to turn on and off all the time. And then we may have old pumps and components. So these are all inspected in the well inspection. So here's some pictures of a damaged well cap. So you can see that there's a gap there where debris or animals can get into. This is a dug well, and because a lot of these wells are older, the concrete deteriorates over time, so we can get a lot of cracks and openings where, again, debris and animals can get into those. And then old equipment. That's an old jet pump, like probably 60 years old, but it was still working. So I try to identify any things that would come up for replacement pretty soon. Typically, the only thing is that I can't usually identify is the age of a submersible pump, because that's in the well, unless there's some kind of a sticker that the installer left inside the basement or on the electrical box. Typically the age of submersible pumps is not it's not something I could do. Okay, so sorry, I think I ran a little bit longer than I was allowed, but I'm certainly available for any questions that you may have.
Awesome. Thanks so much. Guys, raise your hands if you have questions or put them in the chat. Stefan Marina is asking, does the drip distribution septic system have a good reputation, and are they much more expensive?
Sorry, which one? The distribution?
It says the drip distribution septic system.
I'm not sure. Like, is that one of the ones we talked about, like a Waterloo biofilter, or?
Marina, do you want to unmute and maybe clarify what you mean?
Yeah, sorry. Yeah, so I ran into a property. It's called drip distribution system, and when I looked it up online, like the images, it has like way more pumps, and it goes down into the earth, and I thought like I was told it's a newer system, so I thought maybe you encountered it.
Not that one, but generally with these advanced units, like you're right, they're more complicated. They have pumps, they have electronics. So there's certainly, more maintenance on them and more things to go wrong. I'm a big believer in the conventional system that we showed on one of the first slides. There's no pump. It's all gravity. It's the kind of the original septic system, and there's still some of them going 70 years. Like I've seen from the 50s, and it's all clay, like inside the ground, but they're still going. So we know they're reliable. Unfortunately, they just take up a lot of room now, and that's why we're not seeing them as much.
Okay.
I'm sorry. I have a question to Marina. You ask why they use this system? Is it like specific property that you cannot use the regular one? What's the reason?
The seller just heard that it's very good, so he installed it. Somebody recommended it to him, and it was the first time I've seen it. That's why, but it sounds pretty interesting, so I was just wondering. But yeah, I think it's one of the newer. It's supposed to be like more advanced, better, like more benefits to it. Yeah, so I just wanted to know if anybody saw it.
Yeah, normally you use these kind of systems if the lot is small, or if there is a requirement. It's not coming, like there is some talk about, certain areas we have to have certain quality of effluent that's released into the ground. So, in certain conservation areas, they may want a cleaner effluent released into the ground. So that's the benefits.
The backyard has the Wasaga River, and maybe that's why.
Oh, maybe, yes, yeah. Certain conservation areas do require the treatment just to be more than a conventional septic system.
Yeah, that's probably why. Okay, yeah. Thank you so much.
You're welcome.
Awesome. Tanya is asking, what criteria is required for those still on properties with holding tanks want to switch to a septic system?
Yes, so I mean, it's a good question because a lot of the holding tanks, like because of the new technology now, a septic system may be possible, whereas as it wasn't in the past, because now we do have units like Waterloo biofilter or Algen. But it's not something easily determined like on site. We basically have to do a design. So we have to kind of calculate what the sewage flow rate of the house is, which is a combination of the number of bedrooms and the fixtures like bathrooms in the house. Also, we have to know where the neighboring wells are. So we kind of have to come and do like a survey or like a topographic drawing, or we have to take some measurements of the lot and the neighbor's property and where their wells are, and we have to do a design. So I get asked this a lot, like if it's possible to go on a septic if the house is on a holding tank. And I would say yes. I've seen a few that we were able to design for a septic, but it's not it's not just kind of something that can be determined right away. Like there's a bit of a process to it. But it's possible, especially if it's an older property, because we didn't have that technology. So that holding tank was what made sense at that time. But now there may be an option for a septic system.
Perfect. Brad is saying insurance companies always ask if there is a septic backflow valve. What is it, and how can we tell if there is one?
Well, it's kind of similar to city plumbing. A backflow valve is a one-way valve. When the sewage leaves the home, then that valve kind of will prevent it from coming back. So if there's a backup of the septic, then that sewage cannot come back into the home. It's easily identified with the camera, but other than that, unless you could see, usually in the basement where the pipe leaves the house, there would be kind of a plastic box or a lid, which would allow access to it. So you may be able to see it in the home, in the basement. Generally, though, I can tell you they're very rare on septic systems, because the main reason is a septic tank can back up, it can become full, but once you can't flush a toilet, typically, we stop running water in the home because it's got nowhere to go. So it's not like the sewage comes back, because it's not like a city sewer where you're getting the sewage from the pipes from the street that's coming back. A septic system is just from the tank, but if you stop using water, it's not going to come back into the house. So they're very rare, but I am seeing some like conservation areas, like Lake Simcoe Conservation Area. They do want to see them in their regulated areas now.
Okay, perfect. Did that answer your question? I'm just going to take that silence as a yes. Okay, Mary, you have your hand up. Go for it.
Oh yeah, I have a two-part question. One, are the plastic holding tanks better than the concrete? Do they last longer? And the second question is, are there any drawbacks to pumping out your system early, like half filled rather than fully filled?
Good questions. Yeah. If you talk to an installer about plastic tanks, generally they don't like them. It's kind of similar to, plumbers didn't like plastic pipes when they first came out, like water pipes as opposed to copper. You'll hear that quite a bit. But it's a newer technology, so I think it'll take time. there's definitely one advantage of plastic. I mean, from an installation point of view, it's a very light tank. So you don't need, heavy equipment or trucks to bring it in. If it's a very tough lot to access, meaning like, it's a big hill or you just can't get a truck to drop a concrete tank in a hole, plastic tanks are really your only choice. But at the same time, like because they are so light, if there is a high water table in that area, they're kind of like boats underground. So you have to take precaution and anchor them down. But the problem is, a lot of the times that's not done properly. So I've seen these plastic ones float, and they're just not as strong. So they're okay if you never hit them, but if you run them over with an excavator or a piece of equipment, they can easily get damaged. So that's kind of the main disadvantage. And believe it or not, plastic are actually more expensive than concrete. So there's that factor. But they do have an indefinite lifespan, or supposed to. Like, so if everything is good with them in terms of installation and they're not damaged, then they can practically last forever, whereas concrete tanks can deteriorate. And in terms of your question about pumping, yeah, I've encountered like a lot of literature, or I've read on the internet, that generally not recommended to pump your tank in the winter if you can avoid it. And the main reason for that is that, the septic system is a colony of bacteria. So when you pump it out, which you have to do once in a while to get rid of the solids that will never break down, but you want that bacteria to reestablish itself as quick as possible, because that's what's cleaning up the waste before it leaves the tank or before it goes back into the ground. So if the bacteria is not coming back, that's very dirty water that's being released. So in the winter, generally, if the ground is almost frozen, there's not going to be a lot of bacteria that's able to kind of grow that quickly. So that's one thing that I've heard. Also, depending on the water table, it's always best not to pump a tank when there's groundwater everywhere. So like early spring. And if if you're walking on a property and you're like the grass is wet and because the snow melted or heavy rains, probably not a good idea to pump the tank at that time if you can avoid it, because like I said, these can become boats underground and they will like heave right out of the ground. And I've seen concrete tanks lift right out of the ground. So I hope that answered your question.
Yes, thanks.
Perfect. Well, that was a bit of a scary last sentence, that the concrete tank can float out of the
Oh,
ground.
yeah.
That's awesome. Can we maybe say something more positive at the end?
Well, I haven't seen it very, very often.
There you go. That's what we
but-
want to
yeah.
hear.
What I can say is septic systems are very, very reliable if they're treated properly. And the two main things with a septic is to pump the tank out every 3 to 5 years. That's to get rid of the solids that that will never break down. So there's always stuff in a tank that shouldn't get in there. And nothing ever eats away at it. So if we let that go, that'll overtake the tank. So every 3 to 5 years, we pump out a septic tank, and just watch what you're putting down. You just have to think of the septic system kind of as a living, organism. So we don't want to put harsh chemicals, things that can kill off bacteria. Like anything in moderation is fine. Like you could do laundry with bleach. You can use regular detergents. Things that aren't advertised as septic safe. within reason, right? So, but you know, there certainly are septic safe products that you can use that will break down. So where we can use those, that would be encouraged.
Amazing. Stefan, thank you so much
My
for gifting
pleasure.
us your time this morning. This was fantastic. And I'm
My
sure we
pleasure.
all
Thank you.
learned a lot of new things. And guys, we're going to send out Stefan's contact information. So if anyone has any follow-up questions that you're just not thinking of right now, or that are coming up as you're going to showings with your clients or putting in offers on properties, just make sure you reach out to Stefan and get those questions answered. I hope you all make amazing things happen today. Thanks so much for coming. And we'll see you next time with another Feature Friday. Have a great day, everyone.
Thank you,
Thank you.
Stefan. Bye.
Thank you.
Awesome. Thank
Thanks,
you,
everyone.
Stefan.
Thank you,
Thank
Stefan.
you. Thanks. Okay.
Bye.
Bye, everyone.